Okay. So we finish up chapter 1 today, finish up 1.6 and 1.7. Thursday is review. You already have the review sheet. If you did not get a review sheet, see me after class. If you need a brand new homework assignment sheet, see me after class. They're also posted. Review sheet and the homework assignment sheet is posted. Please remember, have your homework ready to turn in on Tuesday next week. It is due at 10 o'clock. The longer it takes to collect the homework, the longer it takes to start the test. So people are going to be waiting on you. So show up with it in order, all of the homework assignment page filled out, because that's your cover sheet. If it's not there, you're going to have to fill another one out. People are going to wait, stapled together in order, complete. Okay. The neater, the better. Okay. And then once I collect those, we start the test. When it's test days, be on time. If you're late, 10% of the raw score gets taken off. Pencil only. Test is over at 10:50. 11:50. Somebody came. Over at 11:50. If you don't finish on time, I take off 10 points. Real calculators over. Check your batteries. Last thing you want to do is show up and batteries go out. And remember, tests are no notes. No notes, no scratch paper. Everything's done on the test. Okay? This question right here is right out of 1.5. We did this number 19. I haven't posted this number 19 email that posted it where broke down this problem into separate individual records. You're supposed to take this picture of f of x and then add 2 to all those y values. What does it look like if we do f of x plus 2? So the idea is you got to start with the ordered pairs and then figure out how do I change those old ordered pairs to get the ordered pairs that I want to graph. And then the next one, we do something different to it. We change the sign of f of x. And what does that do to this picture? So it starts with the ordered pairs, one little bit at a time. You did it all. Because eventually you see something like this, where you have 3 things happening. On the review sheet, there's 2 problems on the review sheet, number 11 and 12. For practice. You might even recognize the picture for number 11 right here. Huh. Look at that. Different numbers. Same idea. So it's all about the order pairs. So the first thing you want to do is write down these order pairs, not just look at them over here. Write down order pairs. For function f of x, we have x and the f of x value. We have -2 and a +4. We then have 0 and a 3. We have a 1 and a 0. And we have a 3 and a -1. And then remember what this all represents. We're looking at g of x equal to a times f of inside x minus an h, and then plus k. A determines whether it's flipped, reflected across the x-axis. How can you tell if it's reflected? If it's negative or not. If a is a negative number, then we're going to reflect it across the x-axis. A negative y value is going to flip across to the other side. That positive 4 is going to become a -4 if I put a negative in front. That becomes a -4. This -1 has a negative in front. It's going to flip up to a +1. H is the horizontal shift. H has a built-in negative. So it's going to shift the graph left and right, but it has a built-in negative. So when you extract the H, when you take the H out, you're going to take out the opposite side of what you're looking at. K is the vertical shift. It's going to move it up or down. K has a positive in front of it, so you're going to keep the sign on the K for the vertical shift. So when I'm looking at this right here, I'm looking at and identifying what is the A in this problem. It's a -2. So there's a 2 involved as well. So it is going to flip. It's going to reflect, but it's also going to stretch. Think of it as just a 2. If I put a 2 in front, this Y value is a 4. 2 times that Y value, it would stretch up to an 8. It would stretch it. Okay? That's what the 2 would do to it on the outside of f of x. All you do is multiply the old Y value by 2. And since it's a -2, instead of up here, you're going to flip it down here to -8. So don't overthink it. We just need the pieces right now. Pieces of this puzzle. A is a -2. In here, there is something in the parentheses with the x. So what is this H in there? -2. The graph is shifting to the left 2 units. Everything's going to shift to the left. Okay? Going to shift to the left. Because we're looking at +2, x +2. We do the opposite direction. We're going to go to the left. And then we have a K as well. K is a +1. So everything will shift up 1 as well. So these are going to be my x, g of x, ordered pairs. I'm just going to focus on the x's first. Just going to focus on the x's. What are my x's going to be that I want to graph over there? So let's focus on the x's. All of these points need to go this way because h equals -2. They're all going to go that way 2 units. That's the only thing you care about right now. H is -2 because I want the x's. So if this is -2 and I'm going to go to the left 2 units, where is the new x that I'm going to be? It's going to be at -4. So the x in my picture is going to be at -4. In other words, I'm going to take this x and I'm going to subtract 2 from it. This -2, to shift it left, I have to take away 2. I know you want to add 2. I know you do. Stop it. What are you supposed to do? Opposite. Opposite. And I'll tell you why. But I have to jump ahead. The only thing I have answers for is plugging in -2, I get a 3. Plugging in 0, I get a 3. Plugging in 1, I get a 0. Plugging in 3, I get a -1. If you keep this up with the whole add 2, because you see the +2, then when you get to 3, you're going to think that this is 3 + 2, and you're going to want to put in 5. Okay? That means you're supposed to have an answer over here when x is 5. I don't have an answer for an x that equals 5. I don't. What I have an answer for is this. If I go g of -4, g of -4 is equal to -2 times f of -4 + 2 plus 1. So g of negative 4 is equal to negative 2 times, what's negative 4 plus 2?
-2.
F of negative 2 plus 1. So g of negative 4 is equal to negative, f of negative 2. F of negative 2 is positive 4 plus 1. So g of negative 4 is equal to negative 8 plus 1. G of negative 4 is equal to negative 7. I can plug negative 4 in because I'm going to add 2 to it. And then I have an answer back to the original function. That makes my brain hurt. Makes my brain hurt. So, you know, by examination, we're supposed to take out h, and h is the opposite sign. If there's something inside of parentheses with x, you have an h. It's a built-in negative always for h. So when you take out h, and you're looking at plus 2, h is negative 2. These x's are going 2 to the left. So since this was at negative 2, 2 to the left means we're going to plug in negative 4. That's the x coordinate that we're going to plot. Now you don't have to do this to get to y. I'll show you how to do y in a minute. I saw the work you forgot. But it is going to be negative 7. Don't forget it. It's going to be a negative 7. This x was 0. What is it going to be if I go 2 to the left? It's going to be negative 2. So that 0, take away 2. It's going to be negative 2. This was at 1. We're going to go 2 to the left. So it's this 1, take away 2. It's going to be at negative 1. This x is a 3. We're going to shift it 2 to the left. Where we're going to be? It's going to be at 1. So those are all the x coordinates from my new graph. Those are my x's. Okay. Now I need the y's. Everything else, the a and the k affect y. The a and the k change the y vector. The y value is, take the old y value, it's negative 2 times this old y value, and then you add 1 to it. Okay. So right here, this is going to be, this old y value is 4. We're going to do negative 2 times this 4, and then we're going to add 1, because g of x is equal to negative 2 times f of x plus 2 plus 1. So you're going to do negative 2 times the y value, and then you're going to add 1 to it. So the y value is 4. So we get negative 8 plus 1. And remember what I told you, that it was going to be negative 7. So we're going to get negative 4, negative 7. Negative 4, down 7. Negative 1. This point right here, this guy, is going to shift 2 to the left. So it's at negative 4. Then this y coordinate is going to get multiplied by negative 2. So 4 times negative 2 is negative 8. So it's going to flip all the way down here to negative 8. So that's going to be here, and it's going to flip down and stretch down to negative 8. And then we're going to add 1 to it. That plus 1 is going to shift it up 1 to where negative 7 is. We're gonna take this y, we're gonna multiply by -2, so -2 times this 3. And then we're gonna add 1. That's the function, that's d. So we get -6 plus 1, and that's gonna give us -2 and a -5. So the next point is gonna be at -2, -5. Label it. So that's this one. You're at 0, 3, it's gonna go 2 to the left. We're at 3. So if I multiply by -2, this is gonna flip down to -6. It would be here. But then plus 1, it shifts up to where -5 is. And then we have 0. So we take -2 times that 0, and then we add 1. So that's just 0 plus 1. So we're at -1, +1. -1 of 1, and label it -1. So that's this one right here. We're going to go 2 to the left, multiply by -2. So the y value is 0. -2 times 0 is 0. So we don't move, we don't flip. But then you have to add 1. So you're now going to be there. And if you take this last y value, -2 times that -1, and we have 1. So that's +2 plus 1. So that's going to give us 1 and 3. 1, 3. Okay. So that would be this one right here. This is going to go 2 to the left, so we're at 1. Multiplied by -2. So -2 times -1 becomes +2. And then we're going to go shift up 1. We're going to add 1 to that. Take a straight edge. Use a straight edge. ID card, driver's license, whatever. Make a straight line. This is the graph. To the picture. Ordered pairs. Ordered pairs. Now, if I actually did that, and I didn't want to do it on the original graph because it doesn't go all the way down to -8. So chances of it being the scale is always kind of weak. So -4, -7 would be right about here. -2, -5 would be right here. -1, 1 here. And then 1, 3. So if I actually graphed it on the same picture in 2 axes, This one, 2 to the left, it was 4. We double it, it was 8. Put it down to -8 and then shift it up to -7. This was at 0.3, went over to -2. Multiplied by -2, became -6. Plus 1, we're at -5. This was at 1. We went to the left 2 units, we're at -1. Multiply this 0 times -2, we're still at 0. And then we add 1, so it shifted up 1. This 3, -1. Went 2 to the left, we're at 1. -1 times 2 became +2. And then it shifted up 1, moved up to 3. It stretched, it flipped, and it shifted. Left and up. One thing at a time. When I draw the new picture, the old picture had 1, 2, 3 segments. How many segments should the new picture have? 3. On this test, I'll see the new picture have like 18 different segments. It'll be a curve. Not even close.
So this is what we're talking about, is it correct? So if we were to apply that, so G of X would be G of F of X?
Well, no, because I'm not putting one to the other.
No, okay.
I'm not putting, I'm changing. G is a function of transformation
Okay.
of what F of X is. I'm doing stuff to F. So I'm not plugging F into the G. I'm multiplying -2 times F of something else and then adding 1 to it. So it's not, there's not a direct correlation.
No.
Okay. We're going to do 41. Actually, that's a lecture on it. Composition of functions or composite functions. Back in my college days, when I was working my way through school, mixing paint, delivering paint, ocean basketball, all the good stuff. Mixing paint, sometimes we had to make composites. We had to put one type of chemical into another type of chemical, make a different type of chemical, one into another composition. Okay, that's what a composition of function is. So the key for all of the function work, 3 steps. The first step, you always have to show me. You don't show me this first step, then right away I'm going to be looking at, you're going to be losing points, even if you have the right answer. I want to see the first step. If you have an operation with functions, I want to see the rewrite. So if it's written as f plus g of x, I want to see that means f of x plus g of x. Subtraction, f minus g of x, I want to see the rewrite, f of x minus g of x. Multiplication, division. Then you substitute. So don't rewrite it and substitute all in one thing. Rewrite it first. Then you're going to substitute whatever you're supposed to plug in, and then simplify whatever you plug in. So this notation, composition of functions, the way this is read, the actual wording, this is function f circle function G of X, or of the variable X. As circle G of X. Circle function. Composition functions. Here's how you rewrite it. When we see F circle G of X, it means you're going to take function F of X and you're going to plug G into it. You're going to plug one function into another function. And it's always left to right. Whatever you're reading from left to right, this first function, F, is the outer function. Whatever comes next is what you're plugging in. So up here, if I had what is F circle G of 4, this is what I would want you to do. I would want to see, all right, this means the outer function is F, and inside the F function, from left to right, you're now going to plug in G, and inside the G function, you're going to plug in 4. Rewrite it. F circle G of 4 means from left to right, the outer function is F, and then G, and then 4. Now it's just order of operations. Order of operations, parentheses first. If you think this through, I want to take and plug something into the F function. I want to plug in this. So that means I better figure this out first. So you start inside. You do what's inside this parentheses first. So if I'm going to plug something into F, I got to figure out what G of 4 is first. You do the inner part first. You work inside out. G of 4. Plug 4 into the G function, and we get whatever goes in. We get 4 plus 1. What's 4 plus 1?
5.
5. So that means right inside there, this is 5. So one more time, taking you through it. First step, rewrite what this means. F circle G of 4 means F of G of 4. So now we got to figure out what this is. Substitute, plug 4 into the G function. Simplify. G of 4 is 5. And then repeat if necessary. Because we're not done. We now have to figure out what 5 is. So now we know what we're plugging into the F function. We're going to plug 5 into F. Whatever goes in is going to get squared. So this is equal to 5 to the second power. So we get 25. So on the test, at the bottom of the little box, you're going to have what is F circle G of 4. Put your final answer down at the bottom, 25. Substitute, simplify. B circle F of -2. So what's the outer function? From left to right, the outer function is G And what am I going to try to plug into the G function? B of F
-2.
of -2. F of, and I'm plugging -2 into the F function. So we're just kind of unraveling it from left to right. I got to see that step. Because now I know what I'm plugging in to what first. The inside. The last thing I'm going to do is plug something into G. So the first thing I got to do is figure out what is F of -2. So F of -2, whatever goes in is going to get squared. So that's equal to parentheses, -2 is going to get squared. So what do I get? What's that equal? +4. If you don't put parentheses and you get +4, you will lose a point. Because this -2 without a parentheses does not equal +4. It's a false statement. When you substitute negatives, use your parentheses, like it's frozen. So that's +4. So now I know that this is now going to be 4. So now we're just doing G of 4. And in the G function, whatever goes in, +1. So this is just 4 plus 1, and we get 5. Just so the whole class knows, 10 o'clock, everybody, people that aren't in the co-rec. Next Tuesday before the test, I'm just reviewing for the test. Anybody's always welcome to show up, and I've said this before, but you're all welcome to show up at 8:30 if you need more, see more things happening. You're also welcome to come in Thursday because we'll be doing more practice with these functions. We did this kind of practice this morning. So if you want to look at the co-recs, 8:30 YouTube, we did a lot of these substitutions. I even talked about this before class started with them. Get a composition function. So if it'll help you, it's in the playlist Tuesday, Thursday, 203L. Right? Okay. Number 41. So this is the fifth of these operations with functions, number 5 here. When we see F circle G of the variable X, the rewrite is what is F inside is G of X. Because on Thursday, they're going to be doing these. Look at all those composition of functions. So that's what we're going to do in terms of practice. All are will, just like in poker. All of them. Going to the left. Airland. You guys know the whole story about all the deaths and everything in Poltergeist, the original movie. The teenage daughter died, little girl died, and her 41. Happy days today, sorry. Read on your son. 41, f of x is 2x squared. G of x is x plus 4. Three things. One, what is f circle g? I wish they would have written it correctly. 41 part N. What is f circle g? They should have put of x. Part B, what is g circle f of x? And part C, what is f circle g of 0? So on A and B, we're not plugging a number in, we're plugging x in. So rewrite. This means f circle g of x from left to right. We want to know what is f of, and what am I plugging into the f function? What goes inside? G of x. From left to right, the outer function is f of, inside the f function is the next one, g of x. So we start with the inside. I got to figure out what the heck is g of x. So down here, just like before, you plug in x. Well, g of x is just x plus 4. That's all I know. That's exactly what g of x is. It's x plus 4. Nothing, I don't have any numbers I can plug in. So that's the only thing I can do is take this and substitute. So step one, rewrite it. Substitute. Simplify. Well, that doesn't simplify any further. Then we do it again. Now we're going to do f of. This becomes f of. I'm replacing this g of x with x plus 4. Which is what you already did. You did this in 1.3. You did this kind of a question in 1.3 splits. Question 1, part C. Plug x plus 4 into the f function. Whatever goes in, whatever replaces x, you're going to square it, and then you multiply by 2. So if I plug in x plus 4, I get 2 times that x plus 4 squared. X plus 4 goes in for that x, and then I got to square it. Got to simplify now. Substitute, simplify. Order of operation. If I'm going to simplify this, parentheses first. Well, there's nothing I can do with x plus 4. So what do I do next? Should I square it or should I distribute the 2? Distribute it. Square. Square. Exponents before you multiply and or divide from left to right. Distributing that 2, if I distribute the 2 right now, I'm multiplying the 2 before I've done the exponent. In other words, I'm doing this before I do exponents. Okay, I got to do the exponent first. So this is going to equal 2 times, this is x squared plus 8x plus 16. Now distribute it. And to get 2x squared plus 16x plus 32. So f circle g X is equal to room. Two x squared, 16x plus 32. Any question?
I'm sorry, but where'd you get the 8x from?
And we've been doing this many times, but it's a plus b
Oh,
perfect squared, a squared, and 2ab in the middle. That's where the a comes from, a, and then the b squared. So if you're not seeing it, it's x plus 4 times x plus 4, and we got to distribute x squared. There's 4x's, 4 times x, and another 4 times x, and that's how the 8x comes. Right. All right. Yes.
Like that was the 16, in the bottom 16 head.
2 times x squared, 2 times 8x, 2 times 16. So I distributed the two. And to be honest, I understand. But it's different if I put G first. Because here, you're plugging G into the F function. G is going to get plugged into the F function. Now, when you rewrite this, the outer function is G, and we're going to plug F of X into the G function. From left to right, G of F of X. But again, you start inside. F of X is just 2x squared. That's all we know, 2x squared. So we rewrite it. We substitute x into the f function. Well, that's what we get. We simplify it. Well, that's what we have. And then we repeat if necessary. So this is now g of inside here 2x squared. And we're going to plug 2x squared into the g function. And whatever goes into g, I'm going to replace that with a 2x squared. I'm going to replace that with a 2x squared. So this x is just 2x squared and then plus that 4. Substitute. Simplify. I can't go any further. That's the answer. You can simplify. Okay. Part C, they want to use a number. Have circle G to 0. So that would mean from left to right, we're going to do F of, and inside the F, we're going to do G of, and inside the G, we're going to do 0. So I want to plug something into the F function. I want to plug in G of 0. So I got to figure out what G of 0 is first. The inner part is what you have to do first. The G function is just x plus 4. So this is going to be 0 plus 4. Substitute. What's 0 plus 4?
4.
Thank you. So now G of 0 is replaced with 4. We get F of 4. This is now 4. F of 4. So now plug 4 into the F function. Whatever goes in, it's 2 times that thing squared. So substitute. It's 2 times this 4 squared. What do I have to do first? Exponent, 4 squared is. So that's 2 times 16, which is 32. If you have heat at the review sheet, you actually need to try to start. And you'll look at the last question. And you're given 2 pictures. And you're asked to do all of this stuff with it. And then the direction is a big hint. Ordered pairs. That's what it's based on. Understanding that functions have x's and y's. They have domain and ranges. The domain is the x value, the y is the range value. So when I plug in f of 4, negative 4 comes out. So 4, negative 4. F of 3 is negative 2. More about that later. Now, number 68 and 70, we're supposed to use these 2 pictures to figure out this question, that question, and then 7. This is 68. A, F minus G of what? And 68B, what is F times G of 4? So first thing I'm going to do is what?
You're right.
Thank you. Thank you. So listen, where's my diary? Rewrite it, because this is exactly what you have to do. This means F of 1 minus G of 1. So normally you'd be given a function, you got to go plug 1 into F, plug 1 into G, and subtract the answer. But we don't have a function, we have a picture. This is a picture of F of X, that's a picture of G of X. F of 1. F of 1 is the ordered pair. When we plug in 1, we get 2. F of 1 equals 2. G of 1, when 1 goes in, the ordered pair for 1 right there is 1, 3. So it's right in the picture. Everything you need are the ordered pairs. So F of 1 is 2 minus G of 1 is 3. 2 minus 3 is -1. All the rest of the points don't matter. I'm just focusing on F minus G. So rewriting it focuses me on just those two ordered pairs. On function F, it's 1, 3. On function G, it's 1, 2. 1, 2. This is 1, 3 on the G. And then 68. So rewrite it. This is function F of 4 times G of 4. So we got to go find what F of 4 equals. When we plug 4 into the F function, we get the Y value is 4. We're at 4, 4. So F of the 4 is equal to this Y value 4. 4 times. G of 4, on the G function, here's X is 4. What is Y right there? 0. So G of 4 is 0. So G of 4 is 0, and 4 times 0 is 0. Right on the order of pairs. But you have to know what this means. F minus G of 1. So you rewrite it so you know exactly that you just need to, what is F of 1 equal? What is G of 1 equal? Out of those ordered pairs, it's those Y values. Multiply F times G of 4. Rewrite it. So go get the Y value when you plug in 4 to the F function. Go get the Y value when we plug in 4 to the G function. Multiply the two answers. Is F circle G of 1. G circle F of 2. F1, rewrite this. So what's the outer function? F. And what are we putting into the F? G of 1. So from left to right, the outer function is F. And we're going to plug into that the next function, which is G of that one. So we have to find what first? G of 1. So the first thing you do, you start from the inside. Go find G of 1. So the picture of G over here, when we plug in 1, that point is at 1, 3. So G of 1 is equal to 3. So now I can substitute. I can replace that 1, G of 1. And this becomes F of 3. Going to plug 3 into the F function. So now I'm looking for F of 3. When we plug in 3, we get right there at 3, 2 in the picture. When we put 3 into the f function, the y value is a 2. F of 3 equals 2. So G circle, F circle G of 1 is 2. It's kind of like you're trying to work 2 different kinds of spreadsheets and you're trying to match up numbers a little bit. But that's why you got to take it apart and rewrite what you're looking for. What does this mean? It means F of G of 1. So what do? One thing at a time. Don't do everything, do one thing at a time. Go find G of 1. Focus on that. It's just the ordered pair when you plug in 1 to the G. So the Y value is a 3. Then rewrite it. Now you're doing F of 3. Go find the ordered pair when you put 3 into the F. But if you just look at it as one, massive problem in front of you, and you don't know where to begin, this is where you begin with rewriting it so you know what to do first. The inside. Rewrite it on the outer part of G. And inside G is F of 3. We got to find F of 3 first. Well, we already actually have it. 3 F of 3 is 2. 3 goes in, we get 2. So that's now G of 2. So we're doing G of 2 now. So we go back over to the picture of G. When 2 goes in, what's this Y value? 2. So G of 2 gives us 2. So G circle F of 3 equals 2. There's really not a whole lot of work you can show except rewriting it, finding that inner part first, and then plugging it into the next one. Because there's no equations, there's no calculations. Do you understand the concept? That's the key. Just understand the concept. No. 1.7. In mathematics, your entire life, every time we teach you how to do something, then we teach you how to undo what we just did. Teach how to add, here comes subtract. Here comes multiplication, and then we teach you how to divide. Square a number, here comes the square root. In geometry / trigonometry, take the sign of a number, here comes inverse of it. Exponential functions, here come logarithm. In calculus, take a derivative, here comes an antiderivative. Or an indefinite interval. Every time we teach you how to go left, we also have to teach you how to go right. Because if it's a function, we have to be able to go both ways. But to be able to undo what just happened. But here's the deal. Every set of ordered pairs is a what? Relation. Special sets of ordered pairs are considered functions as long as x doesn't repeat. Special sets are considered functions. So I gave you Here is a set of ordered pairs. Let's go -4, +2, -8, -9. I'm just making up some numbers. 0, 7. 5, -4, and let's do this. 10, not 10 negative. This is a function because the x's don't repeat. -4, -8, 0, 5, 10. We never have an ordered pair where the x's. It's a function. Inverse functions undo each other. Inverse functions undo each other, which means they're going to switch the ordered pairs. They're going to switch domain and range. The function's domain is the inverse's range. And the function's range is the inverse's domain. Ordered pairs. One's x is the other one's y. If this is function f, the inverse function would look like this. This is the notation for an inverse function. That is not a -1. Okay, yeah, it looks like one, but it's not -1. In other words, it's not an exponent. When you see this, it does not mean it's 1 over f. First of all, f is not a variable. F is the name of a function. This is the notation for the inverse of that. When you see this right here, the way we read this out loud, this is pronounced f inverse of f of x, or the inverse function of f of x. If I wanted to flip over the function, if I want to actually take the reciprocal, it would have to look like this, f of x, and then in a bracket, 2 and -1. Now that means I'm supposed to flip over the whole thing. So this does not mean reciprocal. It means inverse function. Okay. The inverse function switched the x's and y's. Every set of ordered pair is a relation. Special sets are functions, but not every function has an inverse. Here's the reason. X's can't repeat, but y can. You can have y repeat as many times as you want. So if this is my inverse function, look what happens. The inverse function would have 2 -4. Switch that ordered pair. This one would be -9, -8. Switch the ordered pair. This 0, 7 over here would be 7, 0. This one would switch and become -4, +5. And this would switch and become -9, +10. Now we have a problem. This is a function, yes, but this is not a function. Because if I switch those ordered pairs, I now have an x coordinate that repeats. So here's what I'm getting. Not every function gets to have an inverse. Not every function has something that will undo it unless you cheat in math. Which means, and later on you'll learn this, we restrict the domain. We have to cheat around and do a little creative thinking. We restrict the domain and we say, for these numbers, this is the inverse. But for everything else, we can't have one. Okay? So if this was gonna have an inverse, let's make that positive 9, then we're okay. Nobody repeats. So in order for a function to have an inverse, x and y, they both cannot repeat. If an inverse is going to be there, x and y cannot both be. That's the rule. Okay. It's like this. If the function ties your shoe, the inverse function is going to untie your shoe. It's going to undo what the function just did. It's going to undo it. Let's go. Let's find S circle G of 5. So what's the outer one? F, and then what's inside? G of 5. So we have to do G of 5 first. And I didn't want to give you that. My bad. Let me change it. Let's do G of negative 20. So G of negative 20. So 1/4 negative 20, and then minus 2. What's 1/4 of negative 20? 5. Just 5? Positive times negative? Negative 5. Negative 5. Minus 3, and what's negative 5 minus 3? Negative 8. Negative 8. So G of negative 20 is equal to negative. So now I'm going to plug negative 8 into the F function. F of negative 8. So whatever goes in, multiply by 4. 4 times that negative 8. And then we add 4. Four times negative 8. Negative 32, and then a plus 12. Sorry, build the 3 to front. Okay, I got it. Sorry. Negative 32 plus 12. What is it?
42.
Negative 20. 32 negatives and 12 positives is 20 negatives. Now look. We plugged negative 20 into the composite function. Negative 20 went into G. G changes negative 20 into negative 8. And then we take that negative 8, we plug it into F. What did F do to that negative 8? Changed it right back into the negative 20 where we started. F undid what G did to the negative 20. Like a magician. Change it, put it back together. That's what inverse functions do. They undo each other. Each other means G has to undo F. So if they're inverse functions, when I plug negative 12 into G circle F of negative 12, I should get negative 12. I should be right back where I started from. So plug it in. First thing we're going to do is going to rewrite it. This is G of, inside that is F of negative 12. And we start with the F of negative 12. So F of negative 12 on the inside. 4 times X plus 12. So 4 times negative 12. And then we add 12. That's negative 48. And then we add 12. So F of negative 12 is equal to negative 36. Negative 36. Now, if they're inverse functions, G of negative 36 should change it right back into negative 12. Should undo what F just did. So I plug negative 36 into G, 1/4 of X. So that's 1/4 of the negative 36 minus 3. Positive times the negative. It would be a negative, and 4 goes into 36 9 times. So it's negative 9, and then a minus 3. Negative 9 minus 3, negative 12. Negative 12 goes in, negative 12 comes out. Because they're inverse functions. Because they're inverse functions of each other. They undo each other. If F and G are inverse functions, of each other, then F of G of X, it should be the same for each one, no matter what you plug in. If I plug something into G, if I plug in X, G is going to change it into who knows what, then F is going to come in and change it right back to what you started with, what you plugged in. You plugged in X, it's going to change it right back into an X. If I plug in happy face, it's going to come right back out as a happy face. No matter what I start with, that's what comes out after you do the composite function. And it has to work in both directions. G of F of X. X goes into F, F changes it into who knows what. G undoes that, changes it right back to the X that we started with. So let me show you. How I got these two functions is 3 steps. I came up with that one over there. Let's go with f of x equals, let's just do something like 2x minus 5. Okay. Find f inverse of x. What is the actual inverse function? So you got to come up with the equation. Like I came up with this. I did the 3 steps in my head. So now I'm going to show you how to do them. The first step, step number 1, replace f of x with y. Just replace that function notation, change it to y. Y equals 2x minus 5. Now remember what I told you. Inverse functions, they switch domain and range. The ordered pairs are switched. The x and y change places. That's step 2. Step 2, trade places. Trade places or switch x and y. Just trade the x and y. So instead of y equals 2x minus 5, it's x equals 2y minus 5. Just trade the places, switch the x and y. Step 3, solve for y. That will be f inverse of x. That's your inverse function. So I'm going to add 5. I get x plus 5 is equal to 2 times y. And then I divide. I can either divide both sides by 2, or I'm going to stick with divide each one by 2. So I have y equals, this is 1/2 x plus 5 over 2. So my inverse function to this is 1/2 x plus 5 over 2. Three steps. Watch. If I found the correct inverse function, what am I supposed to get if I do that? If I have the right answer, what am I supposed to get if I plug the inverse into the function? What's supposed to happen? We go back in time. What happens? What is the function going to do to the inverse function? Okay, look, how about this? What would happen if I plug the function into the inverse function? I plug x into the function, and then I plug that into the inverse. What should come out? What do you do? If this was a 9, what should come out? No. 9. If it was a 19, what should come out? If it was just a happy face, what should come out? So if it's an X, then what should come out? They're going to undo each other. So f of x is 2x minus 5. So I now have f inverse up to x minus 5. Well, press these things out, it's just substitution. Whatever goes into the inverse function that we just found, 1/2 times whatever we just got. So it's 1/2 times this, 2x minus 5. And then we add 5/2. I'm replacing x with 2x minus 5. I'm replacing this x with a 2x minus 5, put it in parentheses. Distribute 1/2 times. So it's going to be 1/2 times 2x. What's half of 2?
1.
1. So that's going to be 1x. 1/2 times -5 is -5/2. And then I got a plus 5/2. What's -5/2 plus 5/2? They cancel out. Look what I end up with. It undoes what the other function did. I'm back where I started from because they're inverse functions. They're inverse functions. Okay. So 15 through 18. There's no work you can show, but you have to understand inverse functions switch, and I've said it many times already today, they switch domain and range. They switch the ordered pairs, they switch x and y. Okay, switch x and y. So 15 through 18 on is matching. Okay, look this up off of it. So here's 15 to 18, and over here, A, B, C, and D are the inverse functions, the pictures of the inverse. So 15 and 16, those are linear, they're lines. A, B, C, and D, there's only 2 of those over there that are linear. So let's just focus on the lines for a second. Here's how you tell. They switch order pairs. On this picture of 15, this is 0, -1. So I would have to find the picture that has -1, 0, 1. That's the inverse function. It switches the ordered pair. This picture right here, it looks like it has, well, it's kind of hard to tell any others. Maybe that looks like it's kind of close to -1, -3. So over here, it should be -3, -1. -3, yep, that's kind of close, -3, -1. If I didn't have enough information to find one particular graph, I find the picture that has the switched ordered pairs. So 15 is C. 16, well, the only other one left over would be, but this right here is 0, 6. So the inverse function has to have 6, 0. And this is 6, 0. So the inverse function has to have 0, 6. Which means since it's the same picture, it's its own inverse, which is a rarity. But now you look at number 17. Which of those pictures that we have left is the only possible inverse picture for number 17? And if you had to use common sense,
A.
it's the only one that comes close. Let's say that there was something, there were 3 other pictures just like it. Look at this order pair. This is 0, 1. So I would be looking for the one that has 1, 0. That's how you find the inverse picture. The switch order pair. This one here has 1, -1. So I'd be looking for a -1, 1. So -1. Well, that's kind of hard to do. This one is also -1, -1. But it's also the only one 0, 0. I actually did the example for 74 already when I showed you the 3 steps for finding the inverse. I did this because this is practical. In the book, this is your picture. And it's really hard to tell what the ordered pairs are because you need ordered pairs. And like this one, is that at like a quarter? Is it at a half? They're counting by, looks like they're counting by 2, so that must be 1. So that's at a half. So to take the guesswork, because nobody's going to guess the same thing. And I put that picture on the review sheet as well. I labeled it. Okay. I went ahead and labeled it. And if we play peekaboo with your review sheet, and your review sheet is so much like the test that we'll talk about more on Thursday. Here are the questions, and you would see based upon those pictures. So it's always good to write down the order pairs. Yeah. -4, +4, 1/2, 0, sorry, oops, 0, 2. What's that? Now 2, 1, -1, 3, -2, 4, -4, -5, -4, -3, -2, -2, 0, 0, 2, 1, 5/2 or 2.5, 2, 3, 3, 5, 4, 6. And of course, I wrote numbers on it. Let me do this. In our son. Okay, start with G inverses. We want to plug 0 into the inverse function of G. So we're looking for the ordered pair. If I put 0 into the inverse, the only thing I know is g of x. So remember, this x for the inverse is over here. It's the y value for the function. We switch the ordered pair. So since this is at -2, 0, 0 comes out when x is -2. Since 0, -2, 0 is on g of x, then 0, -2 is on g inverse of x. What I have to figure out, when I plug 0 in for x, this x is g's y. So you have to like put your brain on freeze for a second. 0 into the inverse. So I'm plugging 0 in. That means it's the y from that function. So I'm looking over here. There's 2 zeros. It's this y. Number 96 has no inverse notation. It's just g of f of -4. So what do you have to do first? F of -4. So in this picture, what is f of -4? Positive. That becomes g of 4. So over here, what do we get when we plug in 4? We get 6. That one's straightforward. There's no inverse notation. But then 98 does. But that's why you rewrite it. It's g inverse of f of 3. So what do we got to find first? F of 3. What f of 3? Does that have any inverse notation? Straightforward. F of 3 is -2. F of 3 is -2. Yes. But that's a negative. So this is now g inverse of -2. So on the inverse function, we want to plug in -2. That means on g of x, this x is the y value. So the answer to the inverse, okay, the answer, this y is the function's x. So let's go over here. When -2 came out, it's because -3 went in. And just boils down to rewriting f inverse of g inverse of 6. So you want to start with g inverse of 6. And remember, that's the answer. We put answers for g into the inverse. So going into the inverse, we want to plug in 6. That means on g of x, it was the y value. So what did we plug in to g? We plug in 4. So that means this is the 4. G inverse of 6 is a 4. So now you do f inverse of 4. So that is going to get, that 4 is the Y value that came out of f of x. Remember, what goes into the inverse. Okay, we're plugging 4 into the inverse, but what came out, that 4 came out for f of x, it was the y value that came out. So what made 4 come out of the function? So when you plug in 4 here, you get negative. Okay, so on Thursday, it's on you. Your questions. You ready? Use your time wisely. And you're more than welcome to come to the Go-Rex. Need more time.